Today we are going to learn about multi-step equations or multiple step equations. As a quick review, we'll run through how to work with two-step equations. Here we have negative 2m minus 4 equals 6. Take just a minute, pause the video, work this problem, check your steps and answers with mine. So here I have changed subtraction to addition in my first step. Then I added the opposite to both sides since they were already simplified to get the negative 2m by itself. I simplified that to get negative 2m equals 10, and then to get the m by itself, I multiplied by the reciprocal of negative 2 on both sides. I multiplied by negative 1/2, m equals negative 5. And I can check this because negative 2 times negative 5 is 10. 10 minus 4 equals 6. That is a true statement. So therefore, I have the correct answer. So as a reminder, when solving two-step equations, always make sure that the first thing you do is change subtraction to addition and division to multiplication. As your second step, you're going to simplify both sides by adding like terms. So when we use the word simplify, we're talking about adding like terms. So constants with constants and coefficients of same variables should be added together. Once you have simplified and have only addition and multiplication, we can go ahead and start solving. So then the first thing you do when you solve is add the opposite of whatever is being added to the variable to both sides. And lastly, your very last step will be to multiply by the reciprocal of whatever is being multiplied by the variable to both sides. And that gives you your x or y or whatever your variable is. So let's move on. Now what we're going to be working with is equations with many steps. So often with these, we'll see variables on both sides. So for our first step, what are we going to do? Right, we're going to change subtraction to addition. If you want to put a negative 1 here instead of negative m to help you remember there's a negative 1 as the coefficient, that's fine. Now our goal in solving is to always have all our variables on the left and our constants on the right. If we get our variables on the left, then eventually we'll get the variable by itself, and that will allow us to figure out what the variable is. Now, it really doesn't matter. You could put all the variables on the right and all the constants on the left, but the basic idea is you want variables on one side and constants on the other. So I'm going to start by getting rid of all of my constants over here on the left-hand side. So since I'm adding a negative 5, I'm going to add a positive 5 to give me 0. That's how I get rid of it. And if I do that to the left, I have to do the same thing to the right side. Next, I simplify. So that means I'm going to simplify by adding like terms. So negative 2m plus negative 5 plus 5 is 0. I'm just going to cross these out because they're gone. Bring my equals down. Negative 1m I bring down. And then 6 plus 5 is 11. I'm going to do the same thing with my negative 1m that I just did with my negative 5. I'm going to add the opposite of negative 1m to both sides. When I add the opposite of negative 1m, which is positive 1m, that's going to give me 0. And if I do it to the right side, I have to do it to the left side as well. You can also think about this process as moving your variables to the left and moving your constants to the right. That's often how I think about it. Now, when we add negative 2m plus 1m, we're going to get negative 1m or negative m. You can write it either way on our left. And on our right side, those m's are gone and we're left with 11. I want to pause for just a second and make sure you understand why we added 1m. We did not multiply by the reciprocal. The reason we did that was we were taking the entire term 1m here, or negative 1m, that entire term, and we were trying to get rid of it. And negative 1m is being added to 11. So when you want to get rid of something that's being added, you use your opposite or additive inverse property. Now, if I was just getting rid of the negative 1 and not the m, then I would multiply by the reciprocal. But that's not what I'm doing. I'm getting rid of the entire term, which is being added to 11. So that's why I added the opposite. Now, to get rid of the negative 1m, what we're going to do is multiply by the reciprocal, which would be 1 over negative 1. But that's the same thing as negative 1. So I'm just going to say negative 1 times negative 1. It's just easier. But you can put 1 over negative 1 if that makes you happy. Negative 1 times negative 1 is positive 1. So negative 1 and negative 1 are technically reciprocal because they give you 1 when you multiply them. So I'm left with m equals negative 11. As always, you can do a check step to make sure that you are correct by substituting your answer back into the original equation. So I have 2 times negative 11 minus 5 equals the opposite of negative 11 plus 6. So that's negative 22 minus 5 equals 11 plus 6. So I'm going to change this to plus and negative, and that's going to give me negative 27. I dropped my negative on this 2 right here, so that should be a negative 2 times a negative 11 is positive 22, plus negative 5 is 17, and on the other side I also get 17, so my answer is correct. Let's now move down to the next problem. So here not only do we have variables on both sides, but we also have the distributive property. So let's start with our process here, which is changing all subtraction to addition and all division to multiplication. In this case, we only have subtraction to deal with. So now I have all addition. So over on the left-hand side, we don't have any like terms to combine, so that side's good. But over on the right-hand side, we can simplify. And the way we're going to simplify is we can't add what's in parentheses because they're not like terms. However, we can multiply the negative 2.5 times both of the terms within the parentheses. And this is called the distributive property. So we're going to go ahead and apply the distributive property. Negative 3y plus negative 6 equals negative 5y plus 10. Oops. So the way I ended up with the right-hand side is I multiplied negative 2.5 times 2y, which gave me negative 5y. I brought down my plus, and then I multiplied negative 2.5 times negative 4, which gives me 10. Now I'm going to go through the process we just saw, in which I'm going to get rid of my constants from my left side by adding the opposite, and get rid of my terms with variables on my right side by adding the opposite. I'm going to start by getting rid of my negative 6. It actually doesn't matter which one you start with, but I'll try to be consistent and do it the same way each time to make it easier to follow. So I'm going to get rid of the negative 6 by adding the opposite to it, which is positive 6. And that's going to give me, when I simplify, negative 3y, and those 6's cancel. On the left, bring down my equals, and I have negative 5y plus 16 on the right. I want to get rid of my negative 5y. So to get rid of an entire term that's being added to something, you add the opposite. So we use our opposite property. And if I add to one side, I have to add to the other side to keep our equation equal or balanced. So now I'm going to simplify both sides. 5y plus negative 3y is 2y. And these negative 5y and positive 5y cancel to equal 0, and I'm left with 16 over on the right-hand side. Now I'm going to multiply by the reciprocal to get the y by itself, since I'm left with just the multiplication of a variable. So I multiply both sides by 1/2, and y equals 8. Here is my check step. Now let's move on to the next problem. In this problem, we have the distributive property on both sides. So let's start by changing all subtraction to addition. We don't have any division, so we don't have to worry about that. So we get negative 2 times x plus negative 3 equals the opposite of x plus negative 4. So on the left side, we need to distribute negative 2 times x to get negative 2x plus negative 2 times negative 3, which is 6. On the right side, you can take this negative and distribute it throughout the parentheses, or you can think of it as multiplying a negative 1 throughout the parentheses. Both work. So the opposite of x is negative x, or I'll write it as negative 1x. You can write it as negative x, that's fine. The opposite of negative 4 is positive 4. So now we don't have anything to simplify on either side of the equation, so we can start solving the opposite. I'm going to add the opposite of 6, which is negative 6, to both sides. And I'll end up with negative 2x equals negative 1x plus negative 2. Now I'm going to add the opposite of both sides to get rid of the negative 1x. To get rid of that term, we have to add the opposite since that whole term is being added to negative 2. So I'm going to add 1x to both sides, and I end up with negative 1x equals negative 2. Again, you can write that as just negative x. So now I'm going to multiply both sides by the reciprocal of negative 1, which is negative 1, and x equals 2. Here is my check step to show that I have the correct answer. Let's now move on to the next equation. In this equation, we have the distributive property on both sides. So as always, let's change subtraction to addition. Stay clear of the signs of our numbers as well as our operations. Now we're going to distribute 1/2 times b is 1/2 b. I'd like you to leave this as a fraction and do not change it to a decimal because I want to see that you can work with fractions if I give you fractions. 1/2 of 6 is 3, so this is negative 3. On the other side, 3 times b is 3b. 3 times negative 6 is negative 18. So we're going to get rid of the negative 3 on the left-hand side because we don't want to have any constants on that side. And if we add 3 to the left, we have to add it to the right to keep the equation balanced. So the 3's cancel. We're left with 1/2 b equals 3b plus negative 15. We now want to get rid of the 3b that's on the right-hand side by adding the opposite because it is being added to negative 15. So we're using the additive inverse, or opposite property, to get rid of it. So we're going to simplify both sides. Keep in mind that negative 3 plus 1/2 is actually a subtraction problem, and you have to do 3 minus 1/2 because it's bigger when you're taking the absolute value of the two numbers. So 3 minus 1/2 is 2.5, and we have more negatives than positives. So now we're going to end up having to multiply by the reciprocal, so I'm actually going to write this as an improper fraction. That's actually negative 5/2 b equals negative 15 because those 3b and negative 3b canceled. All right, so now we multiply by the reciprocal on both sides in order to get b by itself. So I'm going to multiply by negative 2/5 on both sides. And this is where multiplying by the reciprocal really comes in handy because we're having to work with fractions. So here, 5 goes into 5 once, and it goes into 15 3 times. And we end up with b equaling 3 times negative, or 3 times 2, which is 6. Our answer is going to be positive because we have a negative times a negative. Here's our check step, and we can quickly tell that 6 is the correct answer, giving us a true statement. And now let's move on to the next equation. All right, in this equation, we're going to have a lot of work to do. Let's start by rewriting with addition and subtraction. Okay, so let's go through and simplify everything we can on each side. On the left side, we cannot add the 4 plus the negative 1/2 because there's an understood multiplication between negative 1/2 and these parentheses. So we have to deal with the multiplication first. Therefore, we have to work with the distributive property. So 1/2 of 4 is 2, and it's going to be a negative. So we end up with negative 2x here. And then 1/2 of 6 is 3, and that's going to be positive. On the other side, again, we cannot add the negative 5 until we deal with the multiplication piece here. So whenever you're simplifying, you do have to use your order of operations. So we're dealing with our multiplication first, which in this case is the distributive property. 3 times negative x is negative 3x plus 3 times 6 is 18, and then we bring down our plus negative 5. Now we're going to add our like terms on both sides. So I'm going to add on the left side my 4 and my 3, and on the right side my 18 and my negative 5. So I end up with negative 2x plus 7 equals negative 3x plus 13. Now I need to add the opposite of 7 to both sides because I don't want to have the constant